Welcome everyone to the special session of the Ontolog Forum. This is today is the 7th of December, 2022, and today we're going to be talking kind of an overview and discussion of principles of data management. So the principles I'm going to be briefly discussing are the GDPR, FAIR, Trust, Metadata 2020, and an example of 10 commandments, which this is for ethical medical AI. There are many other principles that have been proposed prior to these and after these. So I'm really not going to make any attempt to give a thorough overview of all of these, more to give you an idea of what the better known ones are and what their characteristics are. Now, I brought in the General Protection Regulation, GDPR, which was adopted in 2016. It does relate to data, though not so much about metadata or ontologies, but more because it's a regulation, not a directive or recommendation. So you really do have to satisfy it. Well, it seems to me that there are other regulations that are being considered, and so we in the ontology community have to be aware of these, so that we can satisfy them, try to be proactive with respect to these new regulations. Now, FAIR, this is the main one I'm going to be talking about, is guidelines for findability, accessibility, interoperability, and reuse. Now, a number of things might be mentioned about this. First of all, none of these are new. I mean, the FAIR principles were just kind of a summary of what a group of individuals thought were the most important principles that digital assets should have. It was mostly concerned with scientific data, but they certainly can apply to other forms of data as well. And it's also helpful to note that the acronym FAIR does not mean that FAIR is about fair, lowercase. So you have to be careful about that. I've seen people who said, hey, for fairness, shouldn't we look at fair? Actually, it's not about fairness. So we have to be careful about that. So the FAIR principles there are actually 15 FAIR principles that are listed there. I highlighted a number of them because I feel they're particularly relevant to us, although technically all of them are relevant because they apply not only to data, but to metadata as well. And one of the important ones from our point of view is that data should be described with rich metadata. And of course, ontologies are perhaps the richest form of metadata. So that really involves us in this. Another important point that's very interesting here is that metadata should be accessible even when the data itself is no longer accessible. So data that has ceased to be accessible should still have metadata associated with it. That's a very interesting principle. And there's also vocabularies, very important to us in ontologies, that vocabularies should follow the FAIR principles. What I found was interesting about this principle is that it's recursive. The FAIR principles itself includes this principle. So vocabularies following the FAIR principles should use vocabularies that follow the FAIR principles, whatever. So that's kind of an interesting recursive. The others, of course, are all very interesting. I wish we had more time to go over them in more detail, perhaps in a later session. Now, what I would like to emphasize here is that FAIR is not the same as open. The FAIR actually allows for data to be shielded for a number of reasons, privacy, like for GDPR, for example. So what this means is that technically there is no excuse for not being fair. You can't say, well, we can't be fair because this data is not supposed to be public. Well, no, you can be fair without having public data. Essentially, the idea is that you have to be open with respect to the degree to which you satisfy the various principles. So it only requires that you have a process for accessing discovered data, that you have a rich description of the context in which the data were generated, that you explicitly define the conditions under which data can be reused, and so on. So, and it deliberately does not address moral and ethical criteria. So it very definitely is not addressing fairness. So the idea is that fair data need not be open and open data need not be fair. But that does not necessarily mean that fairness is, that these principles are perfect principles. There are definitely ways in which they can be improved. And Gary's going to be talking about that when he gets the floor later on. So anyway, so let's move on. Just remember that fair is not the same as open. And what about adherence to FAIR? Well, there was a review of disaster-related ontologies, which found that very few disaster-related ontologies satisfy the FAIR principles. Of course, as I just mentioned, you don't have to be open to satisfy FAIR. So you have to be a little careful in looking at this. But the 84.1% is really quite striking, that these disaster-related ontologies were not published at all. So it's really interesting. I mean, it may be that the situation has subsequently improved, but as of this particular review, there's quite an indication that a lot more work needs to be done to make ontologies findable, accessible, interoperable, and reusable. Now, trust is a different set of principles. It's not about data, it's about data repositories. So it describes the characteristics, they use characteristics rather than principles, characteristics of the repositories that store data, you know, kind of what their responsibilities are. As with FAIR, these characteristics are not especially new. We had a big initiative called the Open Ontology Repository some years ago, and many of the characteristics that we identified for the OOR are also included in the trust principles. So trust was really built on existing principles, and it was published in 2020, so it was just a couple of years ago. And it's concerned with entrusting, in other words, giving over to another to care for, protect, or perform. It does not guarantee trust, but is intended to help ensure trust. So just like with a FAIR acronym, trust does not mean trust lowercase. It only means intended to help earn trust, or trust has to be earned after all. So here are the characteristics for the trust for trust. As you can see, there are quite a few of these characteristics. Most of them are pretty clear in what you would expect. And as I say, many of them have already been discussed in the context of the OOR. We also had an Ontology summit where one of the tracks was concerned with sustainability. So all of these are things that have been seen before. They're not particularly new. One thing that maybe, switching back a bit, doesn't seem to allow me to go backwards. Oh well. Anyway, perhaps later on in our discussion, we could have a little more discussion about responsibility. Okay, now I'd like to talk a little bit about another set of principles. This is Metadata 2020, also fairly recent. This one is interesting for us because it's about metadata after all. And it's a group. It's actually a collaboration of individuals who are advocating for richer, more connected and reusable open metadata for research. So this is again concerned with research data. The principles are based on existing practices, so it's not particularly new, and intended to complement and support FAIR data principles. So here are the principles: compatible, complete, credible, and curated. It's not exactly clear how much this adds to FAIR and trust. But what I think it does add is that there's a collaboration that is not only producing these principles, but also producing a lot of other, artifacts and suggestions, practices, use cases, understandings, also various criteria about the responsibilities of creators, custodians, consumers. Well, what are the responsibilities of the different personas connected with repositories? So this is interesting because it's an active group that is engaged in producing all of this. I glanced at some of the individuals who are involved in it, and I did recognize some of them, but I'm not sure there's a lot of overlap between our community and their community. Finally, I'm going to look at ethical medical AI. This was published in 2021, so it's even more recent. It's intended for the specific domain of medical AI, and is intended to provide commandments, kind of a checklist of the ethics that should be followed in medical AI. So it's not really about data, although to some degree it does overlap with what we do. One thing I do find a little awkward about it is that it's stated in terms of commandments rather than principles. The nice thing about something like principles or characteristics is that they allow for a more nuanced conformance. Whereas commandments seem to be all or nothing. You really must satisfy. It's almost regulations. So here are the first 5 commandments, and I added some emphasis to try to make it clear what they're intending here. The first one is concerned with recognizing what how AI was used within a decision. The second one was how an AI agent was involved in communication. The third is responsibility for an AI decision action or communicative process, which I think would be useful to discuss later on during our discussion session. And then the fourth is concerned with explainability, about which we did have an entire summit that discussed explainability, including explainability for AI. The fifth one is concerned with being comprehensible and repeatable. And that's interesting because AI decision-making isn't necessarily repeatable, which is, and it's not clear exactly how AI decisions can be made repeatable using current technology. The second 6, interestingly enough, I've seen some discussion of these commandments. 6 is actually the most controversial one. Should explanations be based on theories? Or could they be based on something like just experience or some empirical results that aren't actually at the level of a theory? So that's an interesting one, and one that perhaps might be interesting to us in the ontology community. Then number 7 is you shouldn't lie, basically. You shouldn't be manipulative. Number 8, you shouldn't violate any laws. This looks kind of reminiscent of the laws of robotics going back to Isaac Asimov. Number 9 is fairness, should not be discriminatory. And 10 is that ultimately decisions have to be overseen by people, I guess. They should not be performed by algorithms. There are many other commandments of data that have been developed over the years. One of the oldest that I'm aware of is from 1989, which was the Object-Oriented Database System Manifesto. It wasn't stated as 10 commandments, but it did use biblical language. Thou shalt do this, thou shalt not do this. And it's interesting that it was subsequently rebutted by a second manifesto and followed up by yet a third manifesto. So there was quite a lot of manifestos that were flying around back in the early 90s in the database community. I guess it's not surprising that when I did a search for 10 Commandments data, I immediately got a whole lot. This was just the first page. You can see some of those 10 Commandments for data. The one I found rather amusing was the 10 Commandments for divine data quality. What on earth is that? Anyway, so I did look over a couple of these, and some of them really weren't much about data at all. Others were not really commandments so much as just somebody's advice. One of them was actually a step-by-step procedure, which didn't really, that was data collection, that data collection one. It was actually step-by-step procedure, not commandments. So this idea of 10 commandments is being used rather loosely. My impression about these, actually the one I found that was most useful actually did seem to have some content, was the one on data security and data management. But my impression was that these, when you get free advice on the internet, it might be worth what you paid for it. Finally, I thought of a few research opportunities, and I think Gary's going to mention a lot more. We could certainly adapt the FAIR principles to something like scientific simulations. What one finds in science is that their simulations are increasingly common and important, but very frequently they are unavailable and unrepeatable. I know of examples actually of some prominent ones in meteorology that actually have serious problems. I know this informally, talking to some of the people, and they're just completely unrepeatable. And yet people cite them a lot. So actually, it's really ripe for FAIR principles to be adapted to simulations. Also, what about adapting the 10 commandments type things, although not necessarily using this format? And we could recommend improvements. If I go back to it at some point, I could show you some examples of improvements I could think of for how to improve the 10 commandments for ethical medical AI. But I'd rather let Gary get into this when he gets started. And another possibility would be to survey the major ontologies to see to what extent they adhere to FAIR principles and trust characteristics and so on, and perhaps recommend improvements for these. And with that, I will stop sharing.
Ken, Ram here, can I ask a quick question? Yeah, this is an excellent summary. The question is that I missed the first part of this meeting because it's some other call coming in. What are we trying to do here? Sorry.
Basically, I wanted to give an overview of some of the most prominent examples of principles for data management.
No, I understand that in terms of, is this a, the question I have is that, are we kind of focusing part of the next year's summit on this, or what is the purpose?
No, this is more background material. Might be useful.
Is it FYI? Pardon?
But this is not the first part of the summit. Summit is not starting yet. This is a special.
No, this is our FYI.
It's basically an FYI.
Yeah, okay.
For everyone to be aware of these, so that as we move on to the summit, you'll be aware that these are out there, that people talk about them. When data sources and ontologies are going to be published in the future,
I think that's
talk about
important.
FAIR, trust, and such.
I might add as context, when the topic of the summit was discussed, I was asked, are you really going to be spending time talking about FAIR? And I said, no, not really. It's not central to this. And then it was suggested, well, okay, that's interesting to some people. So why don't we have a special session on FAIR itself? And that's what happened here.
Well, I think this is very interesting because what's going to happen right now, is that there's a lot of push on the data science and things like that. But the key aspects people kind of don't realize is that you cannot just take data in isolation, because we are taking data, information, and knowledge. All of them have to be treated. And this talk kind of talks about that in at one level. Okay.
Right. So Gary, why don't you talk about what you think we should do to improve this?
Certainly. So I'm showing my first slide, which is sort of has the major topics of what I hope to cover if there is time. And as I note down here, this is partially based on a workshop that I put together with Lynn and Harris at the recent fall. And I have a link to a description. I hope that I'll be able to stay on because the internet where I am visiting doesn't seem to be strong. So I've given the slides to Ken in case anything happens. But let me start. So essentially, there are 6 points I want to make, which starts with the limits of applying FAIR, even to data. And there are limits on ideas of measuring the maturity of fairness, for example. I'm going to talk a little bit about applying a very simple view of FAIR to ontologies, and we see the centrality of metadata semantics as a part of that. And I'll also, maybe using the same source as Ken, have one slide on the failure of ontologies from some of these simple FAIR tests. I think besides metadata, the other important thing is the role of communities in producing quality ontologies. And so I'll spend a little bit of time on ontology foundry efforts, which is a community that sort of passes FAIR and other things, and just has a simple COVID example to remind you from our prior summit, where we talked about disasters and COVID was illustrated, and some of those ontologies were discussed. I'll spend most of the time on metadata vocabularies for ontologies and give 3 examples, the historical examples leading us up to sort of where we are in terms of metadata for ontologies. We need to go farther than that, but these are important as context. And then if there is time, a slide or 2 on interoperability issues, which is the central issue with FAIR for many people. Here we're going to be talking about interoperability between ontologies, but more broadly between semantic resources, which are involved in ontologies, and ontologies are part of that. So with that, here are some of the limits of FAIR principles, even with data. So how do people know they're being fair? Well, so some of the developers of the original idea developed the idea of a metric score that you could sort of look at yourself and give yourself a score. They realized that there are a lot of concepts in there that was sort of subjective, and they tried to make it much more objective by revising the idea of what's called maturity indicators, or MIs. But even there, you see to some degree of subjectivity and simplicity that is involved in it. So, for example, you get a favorable score of an MI for findability if you implement structured metadata. If you can essentially take an ID, universal ID, and that the link is resolvable. So these are sort of existential ideas of maturity, but they're very simple. But some of the things for FAIR are much more meaningful, deeper. How do you know it's rich? Is it because it's brief but apt and so forth? These are hard things to actually objectively measure by tools anyway. So I mentioned here, for example, existential checks for metadata, that it follows some community-defined model. Okay, but how sophisticated is the community? What's the quality of the standard? These are things that are sort of currently outside of much of what is done with FAIR evaluations, although people are working on that. To me, the issue really, as you go through this recursive effort on making things fair, making ontologies fair, is it's built around common meetings. For example, there's no unique definition for soil or soil density, and there are many different versions of this, at least in terms of vocabularies, really hundreds of them. Each of them could have a unique ID for the term in a vocabulary, but now we have essentially silos of information about soil that are difficult to resolve. Okay. Here's what it looks like when I simply apply some of the FAIR principles to ontology. So before we had F1 for findability 1, and Ken showed a whole list. I have some things for findability and for interoperability, which are, to me, are the rich parts of fairness. And so, you know, there are certainly ontologies have a GUID. Each element that principle 2, ontology metadata. Now, this, to me, richness has the degree of subjectivity. It could be rich in the sense that there's lots of verbiage about it. It could be rich in the sense that maybe it has a lot of axioms. But it's hard to essentially measure this richness in an objective fashion. What are the metrics for measuring richness is the question. Going down to the interoperability, again, the first principle is to use a formal, accessible, shared, and broadly applicable language for knowledge representation. And so we have things like common logic and OWL. We know there are limitations with OWL. When we go down to 2, though, we see something more than knowledge representation. Ontology metadata use a controlled vocabulary that involves FAIR principles. Now you got to sort of, there's a recursive thing about that. You have to sort of, what does that mean in terms of ontology metadata use a controlled vocabulary? I'll have examples of that later on, and we can see some of the issues there. The third one is really also a very important point. Ontology metadata includes qualified references to other ontology metadata. So this allows essentially you to find a relevant ontology to the one you're looking at, because the metadata in that relates to the metadata in this one. Of course, we can be recursive and say, well, what is underlying the very basic issues, particularly of relationships like transitivity and reflexivity. And you can ask yourself whether the elements in the ontology have the same meta properties, and would they have obviously the same supertype? Do they have the same types of relationships between things? And you get into all kinds of issues on that, which involve a deeper look at meaning. Here's a diagram I use to sort of convey some of these ideas. I use some of these slides for the workshop presentation, which I co-organized. If we just replace the word data with ontology or concept, this is sort of a look at what you do to make, in this case, ontologies fairer. So you start with ambiguous concepts over here on the left, and you look at the data, or rather, you look at the concepts in an ontology repository. That's what, as I'm moving from the upper left across the upper part to the right. And so that's what I'm starting with. And now I want to make whatever that is fairer. So obviously we add UIDs and things of that nature in the repository so that people can actually find these. But when we get into interoperability, for example, we're talking about a common semantics now. Now, it could be more than a representation, because, as you say, you want to do interoperability of semantic mappings. And so what are those types of interoperability semantic relations between semantic resources and ontologies? That turns out to be a difficult issue to resolve. I think this might be the same study that Ken referenced. Mezanwe and friends did a study called Implementation of FAIR Principles for Ontologies in the Disaster Domain relatively recently, although they looked back at ontologies going back more than 10 years that they could assemble, and they looked at the documentation of that. And as
yeah, it's the same one.
These ontologies, many of which precede FAIR, were not intuitively. So findability level was very low, 1.8. accessibility level was only 5.8. Again, some of this is because people built ontologies and sort of stored it as a file somewhere out there in the web. They didn't have a repository. It could be a graduate level project and so forth. And it's a little bit unfair in a sense that these things were done over a long period of time, and many of which preceded FAIR having a chance to it. If you looked at ontologies in the biomedical domain, and particularly more recently, I think the results would look a lot better. Nevertheless, it does show you the problem, one of the problems with ontologies. Just because you're doing an ontology doesn't mean you're FAIR. And some communities are more fragmented than others. So with that, let me turn to 3 slides on, if there is time, on metadata vocabularies to describe ontologies. The first one, going back well before FAIR, is called the Ontology Metadata Vocabulary, OMV. And it's before FAIR, and it's more than FAIR, although it's less than FAIR also. So I've summarized as Ken sort of did in summaries of some of these things, in this case, the 8 principles, not commandments, but principles, very general. The idea, this is preceding FAIR, so we didn't really necessarily have all these ideas of using IDs and things of that nature, resolvable and so forth, as uniformly as we do now. But you'll notice that accessibility, reuse, and interoperability are a part of it, but we have other things like usability. And the number 4 to me is one of the key ones, conceptualization versus realization. It says metadata, metadata for ontology, must reflect the distinction between the underlying semantic conceptualizations, which I emphasize, and particular realizations as concrete ontological digital artifacts. This latter part, the concrete ontological digital artifact, is what you put into a logical language. Represented that way, and maybe in notes and things of that nature, or it's a conceptual model, which I think is very useful. So there's a distinction there that's important. Of course, documentation is mentioned, extensibility, obviously, and expressiveness is also important. Now, people can follow those, but they really didn't have detailed specifications. So, for example, they didn't put any of their rules into a logical language that you could follow. They didn't use an ontological pattern or something like that. So some 10 years later or so, an improvement was made on something called MOD, Metadata for Ontology Descriptions and Publications, by Dutta, Nandi, and Shadi. And they wanted to make ontologies easily identifiable and usable, findable. Again, this is around the time of FAIR, but a little bit preceding the publication of FAIR. And what they were looking at was work in ontology repositories and thinking about how can we help people find the relevant stuff in there. And they did both a bottom-up survey of what the searchers, what's important as a part of a search, what are people using to search these, and let's make sure we define principles for those important aspects. And they also took a big picture view. So this is better than OMV in several ways. And they also express principles in operational terms too. So here are the 8 parts. Again, I'm not going to go through these as Ken's examples also don't go through all of them, but just think about the guideline for brevity and clarity and simplicity and even authority. These are, again, sort of human processable and judgments. They lack a bit of guidance on how to make this machine operable for the ontology metadata. You can understand. I mean, is the machine going to tell you that this has got the right level of brevity or clarity or simplicity? Nevertheless, they did provide a lot of guidance on that. When you get down to 8, for example, vocabulary should be interoperable. And again, they are limiting to the idea of major knowledge representations rather than common conceptualizations. What makes that compatibility between other vocabularies as part of an ontology? 2 vocabularies may use the same term, but they might have very different schema organizations. They might have very different definitions. Just because you're using an OWL doesn't mean they're compatible. is that some people following this, like in the ag domain and the ag portal, which is a repository for things, they had 346 properties for existing metadata vocabularies that you could use to describe. And so you quickly realize that you want to have some focus. And so the idea of what's required, what's the minimum information reporting, can we agree on that? And that's the last example called Miro, which came out of the Obo Foundry effort. Which is, again, a coherent community, has principles, has guidelines, has tools. There'll be more about Obo Foundry efforts as part of the summit, and including a lot of the tools to resolve some of these issues. So I'm not going to necessarily go into them. But again, Miro has many information items as a minimum, but many of them are these trivial things that aren't rich, like an ontology name or a license or the URL. But there are more important parts to focus on that involve some semantics that becomes challenging, although interesting. So for example, 9 and 10 of their reporting requirements, you have to specify the ontology relationships. They must be documented. So something like the environmental ontology or the gene ontology, has a set of relationships that you can look at. They say not only say which are used, and you can look at the RO relation ontology as part of that effort and see all them all listed. The answering the question of why are you using them as opposed to a relationship in, say, Dulce is not necessarily clear to me. I think 10 is a very important principle, but the recursion makes some problems for it. You got to document the axiom patterns as a regular design. Now, I'm writing an article with a co-author about some of these issues, and I'll spend a little bit more time in the article on that, about the grounding axiom patterns. I give an example of one down below for soil, which again I use as an example of something that has lots and lots of definition. Material, its subtypes include Lespa soils, which is a particular shallow type of. It has relations like it has some quality porous and has some parts sand. So this is a good start. But if you were looking to see how this ontology about soil relates to another one, they might have very different labels for them. And even the supertypes might have a different name than environmental material. And they might have, again, they might use Dulce relationships. So there is a challenge here, although I think this is very much in the right direction of documenting this. Last 2 slides here or so is something as a reminder from our previous summit, when we had people coming in talking about disasters, and the COVID pandemic was a big one. And so this is sort of partly a replicate of that. This represents some coherent work out of the Obo Foundry group. So they have many different ontologies, and they're relatable because they use similar relationships, and they make an effort to make sure that they have similar labels and definitions for things. And so you can see the range of things across here. Some are just on the bio part, like a cell, but they were challenged when they got to SARS, because SARS doesn't involve the infection. The COVID infection doesn't start with a cell infection or infection using something, a cell. It's a virus. So they had to adapt the existing ontologies about infections to include a viral thing, which is non-cellular. On the left, you see a little bit of what the structure allows you to connect these things is they have very general ontologies, like ontology of general medicine, OGMS. And then we have an infectious disease ontology, more specific, but it's an instance of you get disorders out of infections. And then they created a new one, VIDO, which is a viral-oriented infectious disease. And they had to modify a range of things to do that. But that is an example about how you can do interoperability. It takes some effort to harmonize things across that, but Obo is a good example of that. But it gets very complex. How do you specify this interoperability of semantic relations? And so here's something from the infectious disease ontology, its definition. It has an ID, as you can see. And it has a definition in text and also links to the same definition in many locations. So they're coordinated in the sense they are aligned. And they also have cross references, X references down here. There's many. So SNOMED is sort of is a very large body of knowledge, and they sort of tell you where to look for similar things in SNOMED. And of course, then they also have to deal with synonyms. So this is a very good effort, but it is still a bit shallow and could be richer, because mostly it's depending on things like synonyms and labels at the vocabulary level. But it is an honest effort and represents sort of a good place to look at the standard. My last slide is arguing that we do need something richer to align and relate ontologies. Most alignment is done by this idea of equivalence, subsumption, disjointedness, for very simple logical relationships, but there are good reviews on alignment. I have one example here. They've had annual meetings on alignment, and there hasn't been much progress in 5 years between 2015 and 2020 in terms of what they're able to do. But there are alignment tools. The question is, in my mind, how good are the semantics of the relationships? And I think that that's the challenge there. Finally, something we'll hear about in the summit, sort of the last half of the summit, more on his ontology design patterns. So there are some extensions to that to sort of have good baselines for ontology design patterns, and there's even a language to facilitate sort of connecting these things. So interoperability, I think, will be supported better by that. With that, let me stop this and take questions for me and for Ken, or have cross discussions too.
Yeah, so
I see there's one message in the chat. I don't know if that's relevant to.
no, that's
Okay.
because Ram had to leave.
I see. Okay. All right. Any questions for us or discussion points that you want to?
Ravi, you put some things in the chat.
Can I first begin with you, Ken?
Yes.
And then move on to, of course, I have put it in SOAP chat. So the lineage of metadata starts from Dublin Core, FGDC metadata, etc. But you did bring good points like what efforts in 2020 and 2021 have been made. The metadata do have usefulness, even if you treat the whole metadata as a stub or a design pattern, because each user can base it on same metadata model or very close extensions of metadata model and apply it to different domains by creating their own data stores. So keeping the access to metadata but not to actual data has a lot of merit. And my own experience is that I had certain level of access, let's say, to security, but I wanted to design knowledge base that was above my security level. So I used the metadata model type of RDBMS model and populated some fake or imagined conforming data types in the store so I could test the design pattern, but actually leave the people with those accesses at higher level to actually create their own data stores, which they needed. So the metadata has a lot of good, and your talk has brought that nicely, but I just wanted to add that point to.
Great point. Very good.
I will let others talk to you while I think of what else to ask.
Terry, you had a comment, or you just?
Terry Longstreth.
Oh, okay, yeah. Can you hear me?
Sure.
Oh, good. I frankly came to this with a different perspective. I didn't understand what we were talking about at first, but to me the issue is only joined by describing how you can do things, and we still need to have a follow-up or a follow-on that says, and we do these things this way. Fair and trust really don't give you much guidance in that regard. And more importantly, there's no way to know that those trust and fair principles are actually being used correctly, or that the data once registered is is preserved, is protected. And, you know, you can put the best ontology in the world out there, and if it's on Wikipedia, somebody come in and fix it, and you won't like that. Anyway, that's my only concern, is that we need to have a social infrastructure around all this. Thanks.
But it's kind of what Metadata 2020 is doing. It is a
Yep.
group it's an ongoing activity where they're providing guidance and use cases, you know.
And
holistic
are they
understandings.
and have they mentioned the ISO standards for data preservation? I don't
See,
think
I don't-
anybody.
I just noted that this group existed,
Okay.
and I recognized a few names of people in the group, but that was about it. I mean, I don't know
Okay.
to what extent they overlap with us.
And I've looked at some of the stuff, but not enough to consider myself an expert. And I don't think they are. They're mostly talking about how to make sure that the graduate students do the right thing. But it isn't graduate students that are going to be protecting this data for the millennium.
Yeah, well,
Just,
it's
I would just
clearly
make,
scientific data that they're talking about,
Well, sure, but you
would-
still have to protect it.
right?
I
Eric?
would just like to make three
Terry-
related points, I
Terry-
think, about this.
Terry makes a good point. Terry, provenance standards do allow that. Also, HIPAA standards insist on keeping track of data in motion, so that how many people have during transitivity viewed the data is also to be recorded. Not only those who have modified or created, but those who have seen or viewed sensitive data and metadata. I just wanted to comment along your observation.
Right.
And
I wanted to
Terry?
add,
Terry.
I guess I should put my hand up. I wanted to add some things that are relevant and useful as we follow these guidelines and principles. Some of the principles talk about them directly, which is the degree of documentation provided helps us understand why something is better than another. Document procedures and so forth. Openness is also important, so that you're open to people seeing the documentation, understanding the axiomizations, for example. And the last thing is that community discussion is sort of implied with what other people said. So that the idea is that the community as a whole, which is part of the scientific community, keeps this thing up to best practices. And so we rely on those things working together, the good documentation, the fact that they're open, and that the community can discuss these things and sort of has an investment in making these things the best that we can.
Rob, you have your hand up.
Yes. My experience of about 5-10 years in NASA, in Earth observation area, uses metadata models so extensively and heavily that hundreds and thousands of users use the metadata repository model to either subset or filter or customize their own usage of that metadata repository. So for extracting relevant, recent, or whatever your geographic region or geospatial region or temporal region, those subsettings metadata are a great tool. I still agree with what Ram said, that we need to go beyond data to information of value and to knowledge and wisdom ultimately. But in that progression, metadata would take us a step closer to building good ontologies rather than just basing on ordinary data designs. What is your thinking, Ken?
You're muted.
One point that perhaps is worth mentioning, and this Gary, you brought this up. Many of these principles are not operational, so there's more. We want to emphasize the operational aspects. How you actually do these, how you use these,
And how they will be used in the future.
and how they be used in the future, right? So,
And the future goes on forever.
yeah. So there's and that's kind of what I also brought up when I mentioned simulations. Simulations are not data, but they're also very important in science.
Yeah.
They're not data, they're not theories, and yet they're very important. And at the moment, they're generally quite closed. You know, a research group has their simulation, and they're not going to let anybody else see it. You know, how do you know it's any good if there's, you know, no oversight? Nobody else can see what this simulation is doing. To what extent can you trust it? At the very least, you should have good metadata. If you had, if you have a good process of showing what is in your simulation, right, then you have at least made some steps toward being more open. Something that we don't have yet.
So simulation conforming to metadata rules or patterns would be what I was also mentioning you in that DoD example.
Right. I mean, this goes on in DoD, it goes on in NASA.
Yes, or
Yeah,
healthcare.
So
It's
I have
getting
my
to be
hand
very
up.
common. Yes, Gary?
I have my hand up here. A comment on metadata. Like data, metadata is distributed. And so just talking about metadata, it may not be very formalized. It may have alternate definitions. And this is a big legacy problem. I'm sure NASA has this problem. Parts of NASA that I've interacted with certainly have that problem of having having alternate definitions, and you don't have a common agreement on many of it. So to use a big metadata repository, the question is one of trust as well as other things, which is, do you trust that to have been maintained so that any additional knowledge about this topic and its relationships to others has been updated? And so when you get to the reality that metadata like data is distributed and ontologies are now distributed underlying, interoperability or harmonization becomes a central feature, which was not well developed in any of these standards. It underlies interoperability, but they really didn't address it directly.
Yeah, I would mention, with respect to trust, responsibility. It isn't, they do mention responsibility. It's not exactly clear to what extent they explain what that means. But if you have legacy data, who was responsible for that? Right? Who is responsible for the data right now? Who was responsible for it in the past? Who created it? Right? So there's this whole chain of responsibility that I think is largely lost over time.
And that's particularly important in the area where the ISO standards I talk about are concentrating. I can give you that. I'll put it in the chat.
Why don't you put a link in the chat? That'd be helpful. So is there an ontology of responsibility? Are there tools for tracing responsibility? I know Mike has some comments about that, but you have your hand up, Ravi?
Yeah, but is Mike, you can go ahead first.
Oh, I didn't have any comments at the moment, no.
Okay, Mike, so thank you, but I wanted to raise a comment or give a comment about trust and fair. Among these two, trust seems to be more amenable to maturity concepts. As imagine a commercial relationship beginning, you have done 100 transactions, reliability, you trust that party more. So financial parties, the trust building is one aspect. Writing all the trust related requirements in the contract is another aspect. So trust is more amenable to maturity than fair, it would appear to me. That's all I wanted to comment, Ken.
So I would add a comment on this trust. So if I know that Ken is responsible for this particular ontology and has been responsible for some, I'm going to trust it because I think he's a responsible person. That's the one element of trust, the R part. But other parts, I might not know the people, but documentation may tell me the tools that they're using, which is in trust. The first T is for to me. So it isn't just like the person's responsible, it's
We are
know of and
losing you.
like and things
Yeah.
of that nature.
Yeah, Gary, you've been dropping out.
Yeah,
Yeah, I'm sorry. As I said, I have more than one person using the internet here, so it's
So yeah, we lost a bit of what you said, unfortunately.
well,
So-
if I can repeat it, maybe you can use a redundant communication approach.
Yeah,
It sometimes works. The idea that as part of trust, if I know Ken is responsible for the ontology, I'm going to trust it because I know some of his practices. But for other people, it might be the tools they're using, the technology, that part of trust. And it also is very important for the idea of transparency. Can I is it well documented? Can I go in and find out what relations they're using and what type of analysis that they might have considered? That's the case, for example, with the viral ontology, infectious ontology, where they discuss the big scientific issue about how to handle viruses. It was a real problem for the ontologies. They didn't really have a way of addressing it. And it's a scientifically unresolved problem, and they had to find a way around it, which they did, or they think they did anyway.
yeah, that was good, Gary. We've actually run out of time.
one more question, last one. A comment actually. By just examining the rules of financial transactions and supply chain transactions, we have used old web services as well as EBXML, the business language, to execute contracts among two parties. So such transactions imply inbuilt trust. And I've used trust here as an English word rather than the acronym if it means multiple things. So it's possible to use documents to execute trusted transactions, is what I said.
Yeah, I mean, the idea of trust is that you have to earn it over time.
Well, not
Yeah,
always. You can define the rules and from first transaction onwards, you are confining to those rules. So trust can be fairly high in the starting stage itself.
Oh, because it's based on something that you trust.
Yes, it's based on rules that are agreed in financial industry like
Right.
Basel, like financial risks. Mike, you may have more comments on that than I do.
Well, yeah, Basel BCBS 239 says a lot about how data should be managed, including metadata and taxonomies. They don't quite say ontologies, but it does embed a lot of the, I guess, the FAIR principles and being able to have institutions manage data in such a way that the regulators have trust in them.
Thank you.
Okay, I guess
No more
with
questions, no more.
that, we should adjourn because we're,
Thank you so much. It was
Run out.
really a great session from both of you. This we should do more often whenever time permits. And these are good general topics and interesting topics. And probably they relate to our upcoming, most likely they relate to our upcoming summit. Welcome. Thank you.
yeah, thanks to everyone for participating. And with that, I will adjourn.